We are now recording, and I'll go from the current slide. Can y'all see the slide? Yes or no?
Yes.
Okay, good. Okay, I can't get it to fill the screen yet. There it did. All right. Before we get going here, I wanted to check and see if you had any questions. I've found out a couple of things since the last time we met, and then I found out I had to change some of the things that I've said since we last met. So let me go over some of those first. First, sometime or another, I think maybe in this class, I discovered that not everybody could get things that were sent by the messaging. So I subsequently started sending everything by both announcements and messaging. But then I found out, well, let's see, that's not quite true. I can't remember the order of things. But then I found out last night that I cannot send an attachment to an announcement. So I have to send attachments through messaging. So now I'm going back. For all things that are strictly announcements with no attachments, I will send as announcements because I know everyone can get those. But I have no way to send things like tests or labs or things like that except through messaging. So can all of you receive both announcements and messages? Everybody can? Now, okay. It was one guy in another class who was using an iPad, and his iPad did not show. Oh, here's Wise J. Okay. And by the way, I got the thing you mailed me. It came in the mail yesterday. Can you hear me yet? Well, I don't know if you can or not. So do y'all see more than 5 people present? There's Wise J again.
I think it says 9.
You see 5. Yeah, I see 5 now. I see Jay, Latrissa, Kaya, Shun, and Cormisha. You see any? Say again?
9.
Oh, here's Kennedy. Excellent. Okay, Kennedy's here. I don't know if she can hear us yet. So do you see more than 6 people present?
It's 9 people.
9, okay. Tell me some of the other names besides the ones I called out. Now I see Nadiria. Okay, here we are. Nadiria's here. Okay. Any others? That gives me 7. You say there's 2 more? There's Minuet, right? Okay, that gives me 8.
And
Hamilton. Okay, is that Keelan or Cordarian? It's Keelan? All right, welcome, Keelan. Okay, y'all still see 9 people here? Okay, that's how many names I've got so far. So if in the course of things you see a new name pop up and I don't acknowledge them, someone stop me from talking. I know that's hard to do, but and let me know so I can get them marked as present. Okay? Now, like I was saying before, since some new people have come in, I've gone through a couple of iterations since the last time we met. I first started doing everything both by announcements and by messaging. And then I found out somebody in yesterday's class couldn't receive any messages, so I decided to do everything by announcements until last night I found out that I can't do an attachment to an announcement. The only way I can send you an attachment, which would be something like a lab or a test or something like that, is through a message. So I'm going to have to keep messaging. I've just got to work with that one student that I found so far who just cannot receive messaging. I think I found maybe another way to help him, but if not that, I'll have to forward him on to the Dr. James, who's our Blackboard guru, and see if she can help him figure out a way to get his messages. So, do y'all have any issues? All right, no questions? Okay. Then let's only get started where we left off last time. We did finish example 1, but example 2 is not in the on the PowerPoints. So I'm going to have to do that on this screen here. So if there are no more questions, we'll go on and get started. Ready to go? Yeah, it sounds like it. Now, one of the last things we said, I've been saying several times, but one of the last slides, I'm going to forward a little bit to get to that, to remind people who were not here. When you're doing long division, here are the first 2 things you do. You write the dividend and the divisor in descending order of the powers, okay? And if you're missing any exponents, okay, then you have to put in placeholders, they call them, with 0 coefficients to cover for those missing powers. And the example we're about to do is an example of the second one, not the first one, but the second one. What the problem says is divide, I'm going to write it again, same as the one up there, x cubed minus 1 by x minus 1. I'm writing it underneath that one, okay? Now, first thing I'm going to do is check. Is this in standard form? Yeah. 3, 0, 1, 0. Okay? Well, what do you notice about that dividend? It's missing what? Some powers. It's missing the square term and it's missing the linear term. So when we write it down in our division algorithm, the divisor goes on the outside of the house, x minus 1, and inside the house goes your dividend. So you put x cubed there, and guess what you put next? Plus 0x squared. You have to account for every term. You see, you got a exponent of 1 and 0 here. That everything's covered on the outside. On the inside, we're missing 2 terms. So what do we put next? No, not yet. You have to account for the linear term. 0x. Okay? And then finally, we put our minus 1. So now you check your exponents. 3, 2, 1, 0. Blast off. We've got them all covered. Okay? Oh, Jalen's here. Let me find you. I know you're hiding. There you are. Welcome. Anyone else show up? Now I see 4, 5, 6, 7, 8, 9, 10. I think I see 10 people. Do y'all see any more than 10? Cordarian's here. Excellent. Okay. Now I've got 11. Do y'all see any more than 11? Okay. I'm going to erase with somebody else. Okay. All right. We're ready to start dividing now. And for those of you who were not here last time, when you add, subtract, or multiply either numbers or polynomials, Well, that's not quite true of polynomials because you can do them any order you want to. But numbers anyway, you always start from the right and work your way to the left. But with division, you go the other way. And you do it here with polynomials as well. So we'll start with the leftmost term on the outside, x, divided into the leftmost term on the inside, which is x cubed. And how many times will x go into x cubed? X squared times. Perfect. And then you do what? Remember the order. You divide first, then you do what? Oh, somebody remembers. Tuesday was a long time ago. So again, you multiply. X squared times x is x cubed, if my pen would stay writing. Okay? And then you do x squared times minus 1 is negative 1x squared. I'm not going to write the 1. Now, do you see why we had to put the 0x squared in there? If we had put the minus 1 there, you couldn't subtract or add or do anything else because you're missing that term. So that's why we did it. Now, usually in long division, the next thing you would do is subtract. However, I like to change signs and add because now we're dealing with signed numbers, and that helps me from making as many mistakes. If you want to subtract, go on and subtract. But it's the same as changing signs and adding, so that's what I'm going to do. I'll change this sign to a minus, that sign to a plus. Now I'm going to add. And guess what? The x cubes go away, which is exactly what we wanted to happen. What happens next? Add 0 to 1, and what you get? 1x squared. Perfect. And then we bring down nothing. No, I mean we bring down the 0x. We need it in there just to hold the place. Okay, after we've subtracted or changed signs and add, then you bring down, and then you go back to dividing again. X will go into x squared how many times? Plus x times. Okay, put the sign in there too. Then after you divide, you do what? Multiply. X times x is x squared. And x times minus 1 is negative x. Perfect. Okay? And then we do what? Change signs and add. These go away. That's exactly what we wanted them to do. We were through with those x squared terms. Okay, what do we have now? Yes, just x, and then you bring down the minus 1. And then what do you do? Divide x into x will go one time. Then you multiply. 1 times x is x, and 1 times minus 1 is negative 1. Ding, ding, ding. We divided, and it comes out with a 0 remainder. What that means is these two things are factors of this polynomial. Well, I messed up my thing again. When you have a 0 remainder, that means the divisor and the quotient are factors of that polynomial, the polynomial you started with. But you know what? I bet y'all knew this already, because back when, and probably intermediate algebra, you probably learned how to factor x cubed minus 1, didn't you? I know you did. Take the cube root of this as sum or difference of two perfect squares. You do the same thing. You take the cube root of the first term. That would be x. Put the same sign. Cube root of the second term. That's 1. There's your first factor. I don't need those first parentheses. I'm going to take them off. Okay? And then, to get that second factor, forget about the thing you're factoring. Look at this first factor here. Square the first one, x squared. Change the sign and multiply those two together. 1 times x is x. And then square the last term plus 1. That's how they factor, and that's exactly, if I didn't get too carried away with my circle here, that's exactly what we got as the second factor here. X squared plus x plus 1. All right. Yeah. Question? Any question? All right. Good deal. Now you can check it by multiplying. That's not quite a FOIL. It's more complicated. Yes. Question? Oh. It's not, it's a little more complicated, but it's pretty easy to do. You just multiply first times each one of those, and then the second by each one of those, and then combine like terms. They do it for you in the text. You can certainly follow up with that. Now, like normally, after every example, guess what they've got? A checkpoint. And those checkpoints are very similar to ones we just did. You can do those, and you can find the audio-video solution at larsonprecalculus.com for every one of those checkpoints. So please, after class, if you don't have another class coming right up, try to do the checkpoint. All right, any questions on this one? All right to erase? Okay, let me know if I'm going too fast. I very seldom go too fast for anybody except extremely old turtles. Okay. Now, example 3 is also not in the slideshow, but example 3 itself is at larsonprecalculus.com. You can go there and see an interactive version of this type of an example. So if what I'm doing confuses you, go there and maybe they'll straighten you out. Here's what it says. It's divide, I won't write that word again, minus 5x squared minus 2 plus 3x plus 2x to the 4th plus 4x cubed, and we'll divide that by, I'm already going past my by, look at this one, 2x minus 3 plus x squared. Ooh, man. Anything look wrong with this picture? Absolutely. You've got to get them in the right order. So let's start outside the house. How would you arrange the divisor? X squared plus 2x minus 3. That goes outside the house. Inside the house, what do you put? I'm sorry? 2x to the 4th plus 4x cubed. Is that what I heard? Okay. Next. Minus 5x squared. Perfect. Help me, somebody. Plus 3x. Minus 2. Goodness gracious, what a long problem. Okay. Now, what's that again? Okay. Seconds up. No, I'm just kidding. Okay. Let me know when I can go back.
Okay, I can't hear and write at the same time.
Okay. And I'm making you talk too. Yeah. That's something they teach teachers to do. Give students too many things to do at once, and then tell them they're not doing well. No, they don't say that. Okay. Oh, there's Jalen again. Okay. Kwame's here. Oh my word. All right. Has anyone else come in? I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Y'all see more than 12 names up there? No, good. All right. Welcome to the class. We're doing long division of polynomials, and we just decided this one they gave us. We're on page 138. It's chapter 2, polynomial and rational functions. 2.3 is polynomial and synthetic division. That's what we're doing now. And right now we're doing long division of polynomials. This is example 3, the bottom half of page 138. And the problem they gave us was all messed up, all out of order. You can't do long division until you get things in order. Whatever you're dividing goes inside the house. Whatever you're dividing by goes outside the house. And both of those we had to get in descending order. Now, I just saw an iPhone come up, but it didn't say whose. Is someone new entered the class? Was that Jalen? Okay. Okay. If y'all see anyone else pop up, let me know. So the next thing, after we get them in descending order, we make sure we're accounting for every term. And how I do that is look at the exponents. 2, 1, 0. Perfect. 4, 3, 2, 1, 0. Blast off. Good. We got them all covered for. Okay? So once you've accounted for all the terms, you've got them in descending order, then start your division. And again, with long division of polynomials, just like long division of numbers, you start from the left and work your way to the right, unlike most of the other things. So, x squared will go into 2x to the fourth how many times? 2. X squared. Say again? I can't hear you. 2x squared. Perfect. Perfect. Okay? After you divide, the next step is to multiply. So 2x squared times x squared is 2x to the fourth. Perfect. 2x squared times a 2x. 4x cubed. Perfect. Next, 2x squared times a minus 3 is 2x squared times minus 3. Negative, not 5. You're multiplying. Ooh. 2 times 3? 6. I see iPhone again. Who's iPhone? Who is that? Say that one more time. Okay. Say it one more time. My hearing's bad and my speaker's not good. Oh, John. Okay. Fantastic. All right. If I'm not mistaken, this is the first time we've caught you on the now, by the way, if you haven't understood this, I forgot to say this at the beginning. When you see, okay, let me start over an announcement. I made it on Tuesday, but some people are here that weren't here on Tuesday. I hope all of you know we're not coming back to campus next week, right? Okay, definitely not coming back to campus next week. We're going to finish spring term like we're doing now. And what they're naming these courses, and it's a pretty good name, these are virtual courses. This is a virtual classroom, okay? We're just like we would be on campus, only we're at home, okay, or wherever you happen to be. So these are called virtual classes. And for the rest of this term, now if you're already in an online class, you stay in that online class. But everybody else is running virtual classes. Now, the other news that came over the weekend was the fact that this summer we're not going back to campus. We're going to have virtual classes this summer as well. Now, what that means is we will be doing it just like this. We will, whatever you sign up for, unless it says online class, then it's a virtual class. You sign up for a time, you sign up for days, and you show up on those days and time wherever you happen to be and have your class then. And we do the same thing. So it'll be actually with the instructors just like we were in the classroom, except I can't see your lovely faces. Well, and the good news is you can't see mine either. Okay, but never mind. Well, maybe you can. I don't know. At least the top of my head, but whatever. So these are virtual classes. What I was saying to John, I think this is the first time we caught you on a virtual class. It's good to have you here. All right, let's continue. What's that? Oh, glad you're here. And by the way, if you didn't hear earlier, all what we were calling quizzes before are now going to be tests because there's no difference. I mean, we can't have an in-class test because we're not in class. So everything is going to be a test. So I've already on Blackboard changed quiz 1 to test 1 and test 1 to test 2. And in fact, your research paper now counts as a test because it used to count as a quiz. Now it's going to be like a test, but it's just called paper, or yeah, I guess on Blackboard. So, say that again. I still can't hear. Oh, when is it? Okay. The next test will be what was scheduled to be a quiz when we finish 2.3. And I'm hoping we'll finish that today. The bad news is the quiz 2 that is going to be our test 3 is only, I think, in WordPerfect format, and I can't send that to you over the messages, okay? So what I've got to do is retype that. Well, actually, I'm going to copy it from WordPerfect into Word and then correct all the errors. Word messes everything up when you try to change from another version. So I've got to fix all those things. So I'm hoping to get that done hopefully sometime tomorrow. So start looking for tomorrow or sometime over the weekend to get your test 3. Okay, and that will be from 2.1 to 2.3, covering what we've done here. A single page test, like your first quiz was a single page quiz, that's going to be what your the next test will be. What would have been your second quiz will be your third test. And like I said, I wish I had it done already, but let me just tell you what I've been through this week. Besides having 3 classes on Monday, 4 classes on Tuesday, 4 classes on Wednesday, and 4 classes today, I had at least 2 or maybe 3 meetings on Monday, 2 or 3 meetings on Tuesday, and I had 2 meetings yesterday. So they have been eating every bit of time that I've had to, when I would be trying to get things ready for class, I've had to be in meetings. But fortunately, those meetings are mostly over. I've got one tomorrow. And I forgot to say this at the beginning, so let me say it now while I'm thinking about it. In addition to having virtual classes, which we just talked about, everything else at the college is going virtual. All of the advising will be virtual. Okay, you should have received that in an email. All of your, you normally probably do your own registration online, so that's done. But you can go to an advisor, virtual advisor, and get a face-to-face meeting virtually, and get advice that way. The business office, they have a new email address, businessoffice@lawsonstate.edu. That's no caps, no spaces, no underlines or anything, just business office written as one word at lawsonstate.edu. The records office is records, R-E-C-O-R-D-S, records with an S on it, at lawsonstate.edu. Everything that we were doing on campus, we're trying to do virtually now. Tutoring. The Space Center is doing tutoring. You set up appointments and you get a tutor, okay? Everything that we had on campus before, they're trying to do virtually. So if you have any problems doing anything, check it out. I sent, I believe through a message, a bunch of phone numbers and stuff like that from the academic dean That's most of the offices that you would need to get to. You can call those numbers, and that may not be the office number, but it'll be someone who can answer a phone and maybe answer your question. If not, leave them a message and someone will get back to you. So we're trying to do everything we did before. I also put a link up there about the virtual library, so you can check out things, go to the library and find out. I put that, I think, under a message too. So just about everything that was happening before is now going to continue happening, but happen virtually. All right, that's all because you came aboard, John. Okay, never mind. I'm just kidding. Okay. Any questions on anything like that? All right, let's get back to this problem. We're doing long division of polynomials, and the one they gave us in example 3, this is on page 138, chapter 2, polynomial and rational functions, 2.3, polynomial and synthetic division. This is example 3, bottom half of page 138. The problem they gave us was just all screwed up. The dividend was all messed up. The divisor was all messed up. You put the divisor outside the house, but you put it in descending orders of the power, what we call standard form. The dividend you put inside the house, and you put that in descending order, standard form, descending orders. And then you count and make sure you account for every term. I count the exponents, 2, 1, 0. Inside, 4, 3, 2, 1, 0. Okay? So we're ready to go then. We've already started the division. You start from the left, divide the x squared into 2x fourth. That goes up that many times. Then you multiply. We've already multiplied the first two terms. We were ready to multiply the third term, and we were sort of stuck on what 2 times 3 was. So minus what? Minus 6x squared. And then you do what? After you divide and multiply, you subtract, but I like to change signs and add. Okay? So I'm going to change that to a minus, that to a plus, and I've got to change the other to a minus. And since I have a magic pen, I do it very easily. Okay? You don't have that. Dad. Okay. So now we add. The first term better go away. That's why we did it. The surprising thing is the second term goes away too in this problem. Most problems that will not go away, but this one it did. What happens with the third term? You just get, I can't hear, but I think you said x squared, right? Say yes. Okay, good. All right. Then you do what? Bring down the plus 3. Now here's sort of a catch here. Since we eliminated 2 terms here, we get to bring down the second term here, minus 2. Okay? That's because our cube term went out as well as the fourth term, so we get to bring down 2 of those, both of those. Now we divide again. And by the way, this is how you check to see if you're through. If your divisor is greater in degree than what's left over, you're through. But if it's the same or this down here is greater, you keep dividing. So x squared goes into x squared how many times? Plus 1 times. Perfect. Then you do what? Looks like we got someone add to the course, did we? Oh, I see. Okay. Well, yeah, it sounded like that was a good idea maybe. Okay. All right. So then after we divide, we multiply. 1 times x squared is?
1x squared.
Right. 1 times 2x is? 2x plus 2x. And 1 times a negative 3 is? Negative 3. And then we do what? Change signs and add. So I'll get my magic pen out and make that a minus. Okay. And now we add. These two go away, they better. That's what we did. Okay, and then what does this give us? x plus 1. Perfect. Now we check again. This time the divisor is a greater degree than the remainder. That means we're through, or almost through. The fact that we do have a remainder down here means that these two are not factors of that. For those to be factors, they would have to have a remainder of 0. Since they do not, then what we can do is express this as plus x plus 1 over the divisor, x squared plus 2x minus 3. Okay? So that's how we complete the problem. And was there a question? All right. And that's how they sort of wrote it in the book. They wrote it a little neater than I did. They came over and wrote it on the side, 2x squared plus 1 plus x plus 1 over x squared plus 2x minus 3. Okay. Now, in reality, you can factor that denominator. That would factor as x plus 3 times x minus 1, but that doesn't help you any. It's still a rational expression. So therefore, I'll leave it alone. There's no reason. Except for the fact, if you did factor it, which would have factored at the very beginning, you see that x, what did I say, plus 3 times x minus 1, you see that x cannot equal negative 3, nor can it equal 1, because you can never have 0 in the denominator. Okay? Now that was unnecessary in this problem, but it's usually a pretty good thing to check. Anytime you have a denominator, make sure you don't allow any values that would make that denominator 0. Okay? You see, that was true at the very beginning. You can't divide by 0 up there either. So that was the case. Any questions on that? Okay, there is a checkpoint at the bottom like there is after every example. Please do the checkpoint shortly after class. You can go to larsonprecalculus.com and see an audio-video solution for those checkpoints. All right, if there are no questions, does someone have time to finish writing everything? All right, then we'll go on to several slides away. Synthetic division. Okay, does anyone remember how to do synthetic division? Well, one thing I've got to do, I don't know if you can see on my screen, this little box with names and pictures sometimes in them that sometimes gets in the way. Sorry. So let me move this up here. Okay. There is a nice shortcut for long division of polynomials, but only for very special cases. That's when the divisor has the form x minus k. Now, to me, that's sort of blah, blah, blah. Say again? Okay. What I like to say is look at the divisor. If the leading term has a coefficient of 1 and an exponent of 1, then you can use synthetic division. In other words, if you don't see a coefficient, you don't see an exponent, you can use synthetic division. Okay? You don't need to write them in there like I just did. It's probably better not to, but you understand if you don't see it, that means the coefficient and the exponent are 1. If that's the case, you can use synthetic division. If that was 2x minus 3, you can't use synthetic division. If that was x squared minus 4, you can't use synthetic division. The exponent and the coefficient both must be 1. Now, if we were to go back, and I think I will go back, it'll be quite a ways, but hopefully we'll get there, when they did a long division. Oh, here's one that we did. Notice what happens with every long division. This goes away. Yuck. My pen is no longer a pen, it's now a page turner. Okay, there we go. That goes away, that goes away. Let's see the next one. See, this went away, this went away, this went away. We never use that again. Once we do the division, we're through with it. Okay? And you know what? It really didn't matter about the variable either. Okay? They weren't really all that important. They're just extra writing. So let's just get rid of that here. Now, unfortunately, that'll get rid of your variables up here too, but we know what to put back in there. Because if this coefficient is 1 and the exponent's 1, the variable up here will be 1 less power than the variable here. This was an x cubed, that becomes an x squared. Okay? So, yeah, we know what to put back in later. If you go back to earlier ones they did. Oh, I guess they didn't. Okay. Yeah, that was the one. Okay, so synthetic division uses that fact that you really don't use those first terms, so you really don't use the variables until you need them. So let's just make it as simple as possible. So what we do is, now here's a big catch here. Remember what we did when we had to change signs and add? Change signs and add? Well, what they do is that whatever this is right here, following the x, change the sign and put that on the outside. So rather than changing sign every time, just change it to begin with. Make that, if that was a minus k, put a plus k. If that was a plus k, put a minus k. Okay? And then you always, because the coefficient was 1 and the exponent 1, you always bring down that first coefficient. Oh, by the way, let me clear some of my marks out of the way. Okay? What you put here, rather than, okay, you only have one number here. This is a 1 and a 1, so there's no numbers. So just put the k, but put its opposite sign. That way you don't have to change signs and add. You're just going to add. Okay? And then inside the house, you put the coefficients here. A, B, C, and D. A, B, C, and D. But again, you have to make sure you account for every term. That if you are missing a term, you put a 0 in for that term. Does that make sense? All right. And then what you do. I do it a little differently from them, but I say skip a line, draw a line, bring down the A, that first term. And then after that, it's a piece of K. Multiply, put the result here, add. Multiply this by that, put the result there, add. Multiply this by that, put the result there, add. That last entry there, that's your remainder. Okay? Now what they say, let me erase some of my scratch because it's sort of gotten in the way here. I guess I'll erase all of it. Okay. I'll just put this one back in. Okay? What you have up here is the coefficients of the dividend. What you have down here are the coefficients of the quotients. Okay? And then you'll have the remainder. Now with synthetic division, because the term up here is first power, your remainder is always going to be 0 power, so it's always going to be a number. Now, sometimes that number is 0. Okay? That tells you these two things, your quotient and your dividend, are factors of the divisor. Okay? But if that's not a 0, then that means those are not factors, and that's your remainder. Okay? So, like they say, you add the terms vertically, you multiply them at the angles, at the diagonals. To me, that's a lot more confusing than it is really to do it. So let's do one. Well, not yet. This algorithm for synthetic division works only for divisors of this form where the coefficient's 1 and the exponent's 1. That's how I say it. Okay? It doesn't matter whether this is plus or minus here. If this was a plus, remember that's x minus a minus k. So then the k is a minus k. Okay? So just remember, don't let that confuse you. So let's see if now they're ready for a problem. Yes, here we go. Now the question is, I'm going to move No, that's not what I wanted to do. Okay. Well, never mind. Here is your divisor. Does this qualify for synthetic division? Yes, because the coefficient's 1, the exponent's 1. So what do we put outside the box? Say again? No. We don't ever put the x's. We just put a number. What number do we put? What number do we put? Only it's a minus 3. You always change the sign. Remember? Change sign and add. We're going to change the sign on the outside. Okay? Now what do we put inside the house? Before you put anything, make sure that you're in descending order of the powers and that you've done what? Accounted for every term. So what's your first coefficient? 1. What's the second coefficient? Anybody? What's the second coefficient? Help me, somebody. Did I hear a 0? Say yes. You see, you don't have an x cubed term, so you have to put in a plus 0x cubed. You see, there's no x cubed there. 4, 3, 2, 1, 0. You had 4, 2, 1, 0. You're missing a 3. So you have to put in a 0 for that cubic term. What's the next coefficient? Negative 10. Next coefficient. Negative 2. Next coefficient. 4. Perfect. Now here's the test I like to do. I count how many numbers I have here. 1, 2, 3, 4, 5. This had better be one more than the maximum coefficient. If it's not, you've missed the term. So if we had just put 1, negative 10, negative 2, 4, that would have been 4 terms. Coefficient's 4. You need a fifth term. Where did we miss it? There it is. That 0 was missing. All right. So now we got our coefficients in place. We got our minus 3 on the outside. We got the coefficients on the inside. Now my rule, skip a line, draw a line. Okay, that's real easy, right? I've never seen that in the book. I just do it. And you always just bring down that first term. Bring down the 1. No matter what that term is, bring it down. Now you do what? Multiply. Negative 3 times 1 is? Negative 3. You write it right there. Okay, then you do what? Add. Okay, 0 plus negative 3 is? Negative 3. Then you multiply. Negative 3 times negative 3 is? Positive 9. Then you add, and that becomes negative 1. Then you okay? Yeah, because negative 10 plus 9 turns out being a negative 1, right? Okay? Then you multiply. That gives you 3. Then you add, and that gives you 1. Then you multiply, and that gives you a negative 3. Then you add, and that gives you 1, positive 1. Block that one off. Why do I block that one off? That's my remainder. It's not part of the quotient. That's part of that is the remainder. So what is the quotient? It's not those numbers. We have to go back and put the variables back in. So what variable do we put in that first term? X what? A little louder. X cubed, perfect, because you divided x into x fourth, that was x cubed. And then just count down from there. Minus 3 x squared negative x plus 1. What do you do with that remainder? You put it over the divisor, x plus 3. There you have it. This is the quotient part. There's the remainder over the divisor. Does that make sense?
Yes.
Okay. Now, I know that y'all think this is way too easy, so you really ought to do long division because that's more fun, right? I could tell Kermisha was thinking that, right? Nah, I think not. Okay. Let's see how the book does it. All right to erase. Let me just check and make sure I did it right. I think so. So let's... All right to erase, or y'all still writing? Okay. So let me do the erasing. And let's see how they start. It says you should have set up the array as followed. Now, I don't like the way they do it, but it's good. Note that a 0 is included because you were missing the x cubed term. So you had to put the 0 in. But then otherwise, you just do it. Negative 3 on the outside because you change sign, because you're going to change sign to add. Forget about the x's, okay? Change sign to add, that makes it a minus 3, okay? Then you put 1 for that coefficient, 0 for the missing cubed, negative 10 for the square, negative 2 for the linear, and 4 for the constant, okay? Skip a line, draw a line. They do it a little strangely. And you're just going to bring down the first one. That goes to 1. You tell me what to do next. Multiply, and what does that give you? Negative 3. Then, when you add it to 0, it still stays negative 3. Then you multiply, and that gives you, say again, positive 9. Then you negative 1. Then you multiply, and that gives you positive 3. Then you add, and that gives you 1. Then you multiply, and that gives you negative 3. Then you add, and that gives you positive 1. Block that one off. They don't do it. I like to do that to remind myself that's the remainder. These are the coefficients of your quotient. Okay? So they're going to get to this. They did the same thing we did. They even got the same answer. Good for them. They didn't block it off and make it clear like I did. Ha ha ha. Okay? But then you go on and put your x's back in. You see, you took them out to begin with. Now you put them back in. 1x cubed. This is always 1 less than the exponent there. That's because you're dividing by x to the first power. Okay, there's a 1 there, right? So that makes it x cubed minus 3x squared minus x plus 1 with a remainder of 1. Now, they didn't show you what to do with that remainder. Hopefully they will on the next one. Yeah, there it is. So here's the other way you could write this. Your dividend divided by the divisor, this thing here, is equal to the quotient, there, that is here, plus the remainder over the divisor, plus 1 over x plus 3. Does that make sense? All right. Anyone need it up here a little longer? If you do, I'll be saying this again. Notice there is a checkpoint. Please do the checkpoints shortly after you leave class. If you have another class, go to class. Then when you can, do your checkpoints. Okay? All right, to move on. Because if you can't get the checkpoints, you can always go to LarsonPrecalculus.com and get audio video help in doing those checkpoints. Okay. The next things we're going to do are 2 theorems. One's called the remainder theorem, the other called the factor theorem. I wonder where those come from. The remainder obtained in the synthetic division process has an important interpretation, and to me, a surprising interpretation. And that's described here in the remainder theorem. If you have that polynomial, f of x, that's that big long thing that you had, divided by your the x minus k, which, remember, that's what it's required to be in synthetic division, then the remainder, what you get as a remainder, that thing at the end, that remainder, is actually f when you put k in for x. What? But yeah, that comes out exactly that. So the remainder theorem tells you that in synthetic division can be used to evaluate a polynomial function. That is, to evaluate a polynomial for f of x, when x equals k, you're trying to plug in the k, just divide f of x by x minus k. Do synthetic division, put the k on the outside, coefficient on the inside. You know that synthetic division was really easy. It's just multiplying, adding, or multiplying, adding. Really simple stuff. Now sometimes the numbers may get big, but they're still pretty easy. Okay? And the remainder will be f of k, and we'll show that in example 5. Okay, you want to move on? Okay. So use the remainder theorem to evaluate f of x equals 3x cubed plus 8x squared plus 5x minus 7 when x is equal to -2. Now we know one way to do that. You just plug in 2 for everything here. 3 times 2 cubed plus 8 times 2 squared plus 5 times 2 plus 7. Now, yeah, you got calculators and might be able to do it, but if your calculator broke or something like that, you didn't bring your cell phone, that's going to take you a bit of time and possibly making errors. But when x equals -2, that means, now, get this, when it was written in factored form, that was written as x plus 2. So that's, if you subtract 2 from both sides, that gives you x equal -2. So this is what you put outside the house, -2. If it's written like this, you put the opposite of that, which is exactly -2. What do you put inside the house? You're doing synthetic division. Say again? Help me. 3, 8, 5, -7. Okay? How many numbers you got here? 1, 2, 3, 4. What's your maximum exponent? 3. That's perfect. You've got to have one more number than you have your exponent. Then we skip a line, draw a line. It should be a straight line, but that's okay. And just bring down the 3. Now go to town with it. -6. 8 minus 6 is 2. -4. 1. -2. -9. Don't be multiplying, you're adding. Okay. All right, and that's your remainder. Guess what? We don't care what the quotient is in this. We're just looking for what? F of -2. Oh, I did it wrong, didn't I? This is x equal -2. That should be a minus, that should be a minus, that should be a minus, that should be a minus. Ooh, that makes it even worse, doesn't it? Well, we've already found the answer. We know that f of -2 is equal to -9. Well, let's go and check it and see if it really is true. That would be 3 times. Does anyone know what -2 raised to the 3rd power is? Oh, Zach's here. I didn't see you. Okay. All right. Has anyone else come in the class since I last acknowledged somebody? Right now I have 4, 7, 9, 10, 13, 14 people here. Do y'all see more than 14 names up there? Oh, there's Drake, right? Good deal. Has anyone else come in? That gives me 15. Anyone see more than 15? 15 once, going twice. Okay, 15. Anyone go for 16? Okay, we got it. All right. So, the question was, what's negative 2 cubed? Anyone know? It's not that hard. Give me a guess. Negative 8, perfect. Plus 8. And what's negative 2 squared? 4, excellent. What's 5 times negative 2? Negative 10, plus 7. Okay, we got a little more work to do here. 3 times negative 8 is negative 24, plus what? 32, minus 10, plus 7. Okay, let's go from there. I'm going to add the negatives together. That gives me negative 34. I'll add the positives together. That gives me plus 39. I've done something wrong. What did I do wrong here? Y'all were supposed to keep me from making a mistake. What have you been doing? Okay. Let me check my synthetic division. Did I write it down right? I think so. 3 minus 6, 2. I get a plus 5 here, and I get a minus 9 there. That's not right. There's something wrong with this picture.
Let's check that answer.
What's that again?
Let's check that answer.
Okay. Negative 9 is the right answer. Oh, that's a minus 7. Oh! See what you let me do? That's a minus 7, minus 7, minus 7. See, the original problem is minus 7. What were you talking about here, huh? Okay, so let's change. Now we do our math. Oh, let me erase those two. Okay, now it'll work out, I think. Add all the minuses together. That gives me minus 34, minus 7 is minus 41, plus 32. What does that give us? Minus 9. Hey, which was easier, plugging in or doing synthetic division? Synthetic division was way easier. Look, we made a mistake. Well, it's because I copied the problem wrong, but still, I made a mistake there. I didn't make it in synthetic division. That wasn't on purpose, by the way. But you can tell there's more work there. The numbers are bigger, the adding is bigger, the multiplying is bigger, the cubing, you don't even have to cube in this problem, or square, okay? So synthetic division sometimes can make evaluating a function much easier. If you know what you're evaluating it at, put that on the outside, put your synthetic division to work, and when you get a remainder, that's your answer. Amazing, huh? Guess what? There is a checkpoint. Please do your checkpoints as soon as you can. Oh, let's watch how they did it, okay? I forgot they had done this one. Okay? First thing they do, synthetic division, you put this on the outside. Now you put exactly what x is equal to on the outside. If it had been written as x plus 2, then you put the opposite of that. Because if this, say, is equal to 0, which it isn't, but if it was, then you would subtract 2 from both sides, and that gives you x equal minus 2. So these two expressions are the same. X plus 2 or x equal minus 2. Sorry, right there. Those are the same. Okay? So, you put that, what x is equal to, or the opposite of what it's added to, or whatever, on the outside. Put your coefficients on the inside. Make sure you account for every term. There are 4 numbers, maximum exponent 3, that works out well. And then do the synthetic division. When you get to the end, that remainder is your answer. Does that make sense? We don't care about this part in here now because they didn't say find the quotient. All we're looking for is what's the value, -9. Okay? Now what they're going to do, because the remainder is -9, that is your value when f is -2. That means -2, -9 is a point on the graph. Guess what? If you had to graph a really big, ugly polynomial like that, just use synthetic division. Plug in the x, it spits out the y. Okay? That's what functions do for you. Okay? And you can check it by going through and doing the math. They put the -7, that's good for them to do. Okay, and that becomes 3 times the -8 plus 8 times 4 minus 10 minus 7. That gives you -24 plus 32 minus 10 minus 7 is equal to -9. Any questions? Sorry about making the copy error. Okay. Another important theorem is the factor theorem. And guess what? We've already done this, okay? Which is stated below. A polynomial f has a factor x minus k if and only if f of k is equal to 0. Okay? That would be a factor only if f of k is equal to 0. So using the factor theorem, you can test whether the polynomial has x minus k as a factor by evaluating when x is equal to k. So you can either plug it in, or guess what? Use synthetic division. If the result is 0, x minus k is a factor. So here is what they're asking us to do. Show that x minus 2 and x plus 3 are factors of this polynomial. Now we don't know that they are, they're claiming they are. So what would you put outside the house for this one? Say again? You put the opposite of that, which would be 2, right? What do you put inside the house? 2, 7, -4, -27, ooh, big numbers, -18, okay? Do we have enough numbers there? 1, 2, 3, 4, 5, that's one more than your maximum exponent. Yes, we do. We don't even have to check to see if there are any missing terms. We know we got them all. And you can check anyway. Skip a line, draw a line, and do what next? Bring down the 2. Then you do what? Multiply, and that gives you 4. Then you do what? And what that gives you? 11. Then you multiply, and that gives you 22. Then you add, and that gives you, someone said 18. Perfect. Then you multiply, and that gives you 36. Big numbers. Then you add, and that gives you, say again, 9. Then you 18. Ding, ding, ding. What does that give you? 0. Guess what? X minus 2 is a factor because the remainder was 0. Now, you could have gotten the same thing if you'd have just plugged in a 2 here. Does anyone know what 2 to the 4th is, by the way? Yeah, it takes a while to figure it out. Then you have to multiply that, but by the way, it's 16. 2 times 16 is 36, and plus 7 times 8 is 56. Goodness, those numbers are getting big. These we thought were big, but nothing as big as those. So yeah, Much easier to do synthetic division. Now here is going to be a little bit of magic, okay? Because that remainder was 0, to test the next factor, guess what? We don't have to go back to the original polynomial. We can just pick up from here because this is a factor. So if that's a factor of this, it's also going to be a factor here. So what do we put outside the house? -3. Perfect. Then you skip a line, draw a line. And then you do what? Bring down the 2. -6. 5. -15. 3. -3. I mean -9. I'm getting so excited. 0. Ding, ding, ding. We found another factor. Okay? Are we shown that x plus 3 is a factor because x equal -3 gave you a remainder of 0? Okay? But the next part says find the remaining factors. What do these numbers here represent? We know the 0 is a remainder. We're happy with that. What do those numbers represent? They're the coefficients of what? And here's a little hint. When you're doing synthetic division, especially if you're trying to find factors, once you get down to 3 numbers, stop your synthetic division. Because this first is going to be a 2x squared. Continue. Plus 5x plus 3. It's got to be. If you only got 3 numbers, the maximum exponent is going to be 2, then 1, then 0. Okay? So, all we have to do is see if we can factor this. Now, there's a couple ways we can go. We can do trial and error, which shouldn't be too bad in this problem, or we can do the AC method. Which you want to do? Oh, y'all want to do AC, don't you? Okay. So what? My pen's all caught up. Wait a minute. Let me get loose. Okay. So this is your A, this is your B, and this is your C. Okay. So AC is what? 6. And you're looking to get a B, which is 5. Okay. Now what we want, and here's the thing that you have to watch for. We want to find an M and an N so that they multiply to be 6 and add to be 5. Okay? That's what we're gunning for. So we're going to look at all the possible factors for 6. Okay? So and by the way, since they multiply to be a positive number, they both have to be either positive or negative, but since the 5 is positive, they both got to be positive. So let's pick the smallest number that will go into 6. What's that? 1 times 6. That multiplies to be 6, but what is 1 plus 6? 7. That's out of it. Can't use that one. What's the next number that will go into 6? 2 times 3. And what's 2 plus 3? 5. Ding, ding, ding. We found it. Stop right there. Don't do any more. We found the factors. So here's what we do next. You're not through. No, these aren't factors. These are the numbers we're looking for. So you write down the first one. 2x cubed. Squared. Don't make it a cube. That messes up the whole problem. Okay, 2x squared. Okay, instead of 5x, we make it plus 2x plus 3x, right? Is that 2 plus 3 is 5, right? Then bring down the last number, 3. Now, it looks like we just made it worse, doesn't it? We went from 3 terms to 4 terms. But what do we do with a 4-term polynomial? Group them. You're absolutely right. Now, what can you factor out of that first group? 2x. What's left? X plus 1. And out of the second group, what can you factor out? 3. And what's left? X plus 1. Now we have common factors here, x plus 1. So factor that out. And what's left? 2x plus 3. And sure enough, those are your last two factors. So to find the remaining factors, don't keep doing synthetic division, factor. Okay? Either trial and error, or you could do AC method like we did. And if you can't get anything to work, guess what you can do? Quadratic formula. That works every time. Okay? Does that make sense?
Yes.
All right. Let's see how they did it. First, let me see if they got the right answer. They did. So we're out of time. How could that be? Okay. All right. Let's just do this quickly. Sure enough, they did synthetic division. Wait a minute. Yeah. Just like we did. They found the remainder of 0. And then they did the minus 3 into that and came up with the same quotient. They found the remainder 0. Same quotient. They took that quotient and factored it. And sure enough, there's the complete factorization of F. Perfect. Oh, and that was also the last problem. And there is a checkpoint. Do that. So let's do. We'll have to start with the vocabulary next time. Homework exercises would be number 7 is at calcchat.com, 9's at calcchat. Any of the odds 11 through 23 are at calcchat, 19's at calcview. Any of the odds 25 to 43 are all at calcchat, 27's at calcview. 45 to 49 are all at calcchat. 51 and 53 are at calcchat, 51's at calcview. 55 through 61 are all at calcchat. 63 through 69 are at calcchat, 63's at calcview. 71 to 75 are at calcchat. 77 and 79 are at calcchat. 81 is at calcchat, should be. And 83 and 85 are true false. They should be at calcchat. And you can think about doing 87 if you'd like, and 89 if you want to. I hate it when they write the wrong thing in there, but you figure out what's wrong. 91 should also be at calcchat. We'll begin next time with complex numbers 2.4. And in that section, well, we'll begin with the vocabulary, but then we'll move on to 2.4. I'll try to have your next test to you before then. And the 2.4 we're going to do very quickly because there was nothing in the course description that said we needed to do complex numbers, but I just want you familiar with them. So we'll do them, but we'll do them pretty quickly. You're not going to be responsible for any complex numbers, but it's a good thing to know. So anyway, we'll go from there. Any questions? All right. Well, I want you to have a good weekend. That's why I gave you so many homework exercises to do. And I'll even give you a test so you can have something to do inside all weekend. Isn't that kind of me? Oh, James, you showed up. Thank you. Okay. Anyone else come in that I didn't acknowledge you? Speak now or forever hold your peace. Oh, who's getting married? Okay. All right. All right, I'm going to stop it there then. Oh, look at all these beautiful names. Okay. Jamel, did I get you? I don't think so. Okay. I didn't get who you're with either. Okay. Let's see. I think I got everybody else. All right. Good deal. Any last questions? All right, well then I'll end the meeting and we'll see you next Tuesday, okay? All right, bye-bye.